In the next section, we have two different aims. We're going to learn to distinguish between chemical and physical properties, and then to distinguish between chemical and physical changes. So this section allows us to learn how to tell the difference between one sample and another, and what to look for when we're trying to identify different compounds. So first we have to talk about physical properties. If we think of the word property, remember that's like a characteristic or something about the appearance of that object that we're talking about. It does not change the chemical nature of the substance. So in other words, it's going to look that way no matter what. If it changes due to its chemical nature, that's something completely different. What we care about is what it looks like just by virtue of its existence. And this can be things like viscosity. Viscosity is resistance to flow. So if I try to pour something out of a container, if it doesn't flow very easily, something like syrup, molasses, if it doesn't flow easily, it's considered to have a high viscosity. So that's an example of a physical property of that substance. I don't have to change it to see that it looks like that. Texture, what does it feel like? That's very indicative of substances ID. Different substances can be rough, they can be smooth, um, they can be sharp, anything that defines what it feels like. One of the things that you're thinking about when you determine physical properties is you're using your senses. What does it smell like? What does it feel like? What does it look like? We don't want to taste in chemistry. Remember, we're not concerned with the taste of things, although we will talk a little bit about um, how taste can define a substance a little bit later in the year. So, sight, smell, touch, sound, and taste. So remember, we don't want to taste things. Most often, things will not have a specific sound, although you may have heard that maybe boiling water sounds a little bit different than cold water, but that's another subject. Something like color is a physical property. Again, what does it look like? Copper has a very characteristic orangish color to it. That's one of the reasons we're able to define or to identify it as copper. Odor. So you've probably noticed that maybe acids, vinegar, for example, smells sour. That's a physical property of that substance. The melting point. Again, each substance has a very specific point at which it melts. If it doesn't melt on that specific point, that means there's some sort of impurities in there, or it's not the substance that we think it is. Boiling point, again, it's going to boil at a very specific temperature. If for some reason it doesn't, it's not the substance that we're talking about. Density. Everything has a very specific density. Remember, density equals mass divided by volume. If it doesn't have that density, it's not the substance that we're talking about. So again, these are all ways that we can define or identify substances based on all of these different characteristics that they have. Solubility. Solubility means, does it dissolve? Certain substances dissolve in water, some don't. So if it's the substance we think it is and we try to put it in water, if it dissolves, that's one more clue that it's the substance that we think it is. Transparency. Can we see through it? And these are just all ways to identify substances. Chemical properties. Chemical properties are a little bit different because we have to put substances through a test to determine whether or not they have chemical properties. So for example, does it react with water? If we take a sample of sodium and put it in a little container of water, does it react? If it does, then it's likely that it's sodium. If it doesn't, it's not what we thought it was. pH. Does it have an acidic pH when tested? Does it have a basic pH when tested? So these are its ability to react with whatever indicator we expose it to. Flammability. Can it catch fire? Is it combustible? Reactivity with acid. Can I put a drop of acid on an egg white? I can see that the protein will start to denature and that egg white will turn white. If it does, it's probably an acid. If not, it's going to be something else. Physical changes. Physical changes do not change the identity of the substance. It's a change in the properties or how we can describe that sample, but not in the sample itself. It's a change of state. So what we're going to look at or think about is specifically in relation to water, because water seems to be the easiest for us to visualize. We know water has a solid form, which is ice, liquid form, liquid water, and gas, water vapor. So we need to look at the process of going between each of these states of matter. Solid to liquid, we know as melting. When an ice cube turns into liquid water, that's when something melts. These are all examples of physical changes of substances. When we go from a liquid to gas, this is called evaporation. Again, water is still water, whether it's in its liquid form or its gaseous form. The formula is still H2O. If we're going from a gas to a liquid, this is called condensation. And a liquid to a solid is freezing. Two lesser known processes are examples, for example, going from a solid to a gas. So you may have heard of mothballs. So mothballs are something that people keep in their closet because they come in solid form, and then when they heat up, they turn into a gas. They skip that liquid phase. This is called sublimation. Something else you've seen and we'll probably use coming up here on Halloween also goes through the sublimation process. This is dry ice. So if you've ever gotten dry ice is just frozen CO2, which means it will go directly from the solid to the gaseous form. It completely skips the liquid phase. That's why when you put it in a little container of water, you can see in that water that there's bubbles of gas forming and being released. It completely skips the liquid phase. Going the other direction, we can go from a gas to a solid. And if we do this, this is called deposition. So if we have a gas and we cool it down to the point where it becomes a solid, you can think of it like those gas particles are depositing themselves on a solid surface. And the last part of this section is chemical changes. So a chemical change means we have to change from one substance to another. This is how we know a reaction has taken place. Something will be there in the beginning. Its physical properties will change. And if its physical properties change, that tells us we have a new substance at the end of this process. So that means it's gone through a chemical change. Color change is an example of chemical change. Copper starts at one color, and then we know that as copper starts to oxidize, as we've seen in the Statue of Liberty, it then turns green. That's a chemical change. That copper is not the same form that it was in the beginning. A precipitate. Now, we think of the word precipitate as precipitation from the sky. So we know that when water falls out of the sky, that's a form of precipitation, but precipitation can mean something else. If I take two liquids and put them together in one container, what I will see happening sometimes is that liquid will turn cloudy, or I will start to see solid particles fall out of solution. So that's what we refer to as a precipitate. It's a solid falling out of liquid solution. And the formation of gas. If you've ever taken baking soda and vinegar and mixed those two things together, you've seen that they form bubbles. Those bubbles are some form of oxygen or carbon dioxide being released from the reaction. That wasn't there in the beginning. And if something is there at the end that wasn't there in the beginning, that's evidence for chemical change or evidence that a reaction has occurred.